learnt about prime and composite numbers, let us quickly look at some of the questions. What is the sum of any two odd numbers, even numbers? So for each of these type of questions, all we need to do is we need to take examples of odd numbers, perform their sum for maybe 2-3 set of numbers, and then see what different do we observe with the sum. So let us start with the first part, that is sum of odd numbers. So let us consider two odd numbers like 3 and 5. When you add them, you get 8. Consider two odd numbers 5 and 9. When you add them, you get 14. Add 11 and 13. When you add them, you get 24. When you add 11 and 3, you get you get 14. 11 plus 15, you get 26. Now, do you observe something, that every time you are adding up two odd numbers, the result is always an even number. Therefore, what we observe is sum of two numbers is always even. Sum of two odd numbers is always an even number. So that is our first observation. In the second case, we are asked to add two even numbers. So let's see what happens with even numbers. For example, 2 plus 6 gives 8. 12 plus 4 gives 16. 26 plus 2 gives 28. So what are we observing? So in case of even numbers also, the sum is even. So whether you add two odd numbers or you add two even numbers, the sum would always be even. Question number 2. State whether the following statements are true or false. The sum of three odd numbers is even. So is this true, that the sum of three odd numbers is even? So let us try. Let's consider 3 is an odd number, plus 5 which is an odd number, plus 3 which is again odd number. So sum of three odd numbers. And what is the result? The result is 11, which is again an odd number. So sum of three odd numbers can be odd. So the sum of three odd numbers is even. No, it is not always even. It can also be odd. The sum of two odd numbers and one even number is even. The sum of two odd numbers. We have learned that sum of two odd numbers is always even. So, and then even number plus even number would be even. So this is true. Product of three odd numbers is odd. Now let us take examples. Let's consider 3. So 3 is an odd number. This multiplied by say 5, which is an odd number, and this multiplied by, let's say, another odd number 7. So how much would be the answer? It would be 15 into 7, which is 105. That is also an odd number. So if you want, you can try these with few other sets of odd numbers and you would see that this is true. If an even number is divided by 2, the quotient is always odd. Now this is false, because any even number will be exactly divisible by 2. So let us say 14. So 14, when it is divided by 2, what happens to the quotient? The quotient is odd. Now when you divide 16 by 2, what happens to the quotient? The quotient is even. So in this case, the quotient can be even or odd. All prime numbers are odd. So do you think that all prime numbers are odd? Most of the prime numbers are odd, but not all. That's because there is an exception. And what is that exception? That is 2. Because 2 is a prime number which is even. Prime numbers do not have any factors. That is absolutely false, because prime numbers have two factors every time. And what are those two factors? 1 and itself. Sum of two prime numbers is always even. Now, do you think that is true? Let us consider the first prime number, that is 2. The next prime number is 3, which is equal to 5. So 2 plus 3 is 5, which is odd. Therefore, sum of two prime numbers is not always even. 2 is the only even prime number. Yes, that is true. Except 2, all other prime numbers are odd. All even numbers are composite numbers. Again, this is false, That is because there is an exception to it, and that exception is again 2, because 2 is an even number but it is not composite. Product of two even numbers is always even. Let's try, let's say 2 into 4, that is 8. Let's try 12 into 6, that is 72. So product of two even numbers will always be even, and this is true. Question number 3. The numbers 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. Find such pairs of prime numbers up to 100. So basically what are we trying to do? We are trying to find out numbers which are prime numbers and which are made up of the same digits. So one is already mentioned, 13, 31. Now let's look at the sieve of Eratosthenes. Now looking at the sieve, we can very distinctly see the encircled numbers which are the prime numbers. So it becomes easier for us to search for such numbers. So one such pair could be 17 and 71. They are also prime numbers and they are made up of the same digits 1 and 7. Now another such example, can you look for another such example? 23, no, because 32 is not a prime number. 31 and 13 we have already done. 43 it cannot be, because 43 and 34 is not a prime number. 37 and 73, yes, this could be another one. 37 and 73. Is there any other that you could find? 79 and 97. So these are also made up of the same digits. So 13, 31, 17, 71, 37, 73, 79, 97. These are such pairs of prime numbers up to 100 which are made up of the same digits. What is the greatest prime number between 1 and 10? So what are the numbers that we have between 1 to 10? So these are the numbers between 1 to 10. Now which is the smallest prime number? 1 is not a prime number. So 2 is the prime number. Next 3 is a prime number. 4 is a composite number. 5 is a prime number. 7 is a prime number. And then you have composite numbers. So which is a greatest prime number? So the greatest prime number is 7. Question number 5. Express the following as the sum of two odd primes. So let us say you are given a number 24. Now you have to write 24 as sum of two odd numbers which are also prime numbers. So basically two odd prime numbers. Now what are the various possibilities of writing 24 as a sum of two numbers? What are the different ways by which you can write 24? 20 plus 4, 22 plus 2, 18 plus 6. These are some random possibilities of writing 24. Now we want to write it as sum of two odd primes. Now two odd primes, so what you do, since 18 plus 6 is 24, if you increase 18 by 1, that it becomes 19. Now since you are increasing 18 by 1, you will have to decrease 6 by 1, so it becomes 5. Now 19 and 5, both of these are odd prime numbers. So this is one answer. Similarly, you can also say 22 plus 2. Both of these are even numbers. Now if you increase 22 by 1, it becomes 23, which is a prime number and also an odd number. Now since you are increasing 22, you will have to decrease 2. That means it has to become 23 plus 1. But 1 is not a prime number. Therefore, 23 plus 1 would not be your answer. Let us look at some other combination. Let's say in 18 plus 7, we reduce 18 by 1. So it becomes 17, which is a prime number. Now since we have reduced 18, so we will have to increase 6 by 1, so it becomes 7. So 17 plus 7, that is also a sum of two odd primes. So these are certain ways in which we can write 24. So 24 can be written as 19 plus 5. It can also be written as 17 plus 7. Question number 6. Express each of the following numbers as sum of three odd primes. So the number that is given to us is 61. Now, very commonly, how can you write 61 as sum of three numbers? We can write it as 20 plus 40, which is 60, plus 1. But we have to write it as sum of odd primes. Now, let's reduce 20 by 1. It becomes 19, which is an odd prime. Now, the moment you reduce this, if you want, you can increase this. If you want, you can reduce this and then compensate in the last number. So, let's say we reduce 40 by 1 and make it 39, because 39 is also odd prime. So we have reduced 1 from 20, we have reduced 1 from 40. Basically we have reduced 2. So we will have to increase this number 1 by 2. So 1 increased by 2 becomes 3. 3 is also an odd prime. So 19 plus 39 plus 3 is the sum in which 61 can be expressed. Question number 7. Fill in the blanks. A number which has only two factors is called a prime number, because prime number has only two factors, 1 and itself. A number which has more than two factors is called a composite number. One is neither prime nor composite. So the smallest prime number is 2. The smallest prime number is 2. The smallest composite number is 4. That's because 1 is neither prime nor composite, 2 is a prime number, 3 is also a prime number, and 4 is a composite number. So 4 is the smallest composite number. The smallest even number is 2. Because 1 is neither even nor odd. So 2 is even number because it is divisible by 2. Therefore, it is the smallest even number.